Every running application on your system starts a process. A process is an instance of one or more tasks running on your computer. One reason why these are very important is the fact that each process consumes system resources. There is a kernel function called the scheduler that manages processes, assigning and deassigning them from system resources, respecting time, that is how much time the process has been running, and priority, how important that process is. Processes may be active, which means they are running right now, or they may be sleeping. If a process is asleep, it means it is running in the background, waiting for the user or for some event to occur so that it starts working again, becomes active again. There is another class of processes that are called zombies. These zombies are processes that have finished their work, typically, but their parent process hasn't registered that their work is finished. So the process is dead and gone, but the parent process uh, displays it when you query it as if it's still alive. So it's dead, but it's alive. You see, that's where the name zombie comes from. Now, all the time, there are multiple processes running on your system. They are tracked using PIDs. Now let me type this. All right. The first thing here is a PID. The bash process has a PID of this. The PS command that I just ran has this PID. And the PIDs are assigned one after the other in ascending order. The very first PID always is called init. Let me do this. PS E, and I'll pipe it to less just so we can see. All right, the very first process PID is this one. All right, it's written systemd here. In some displays, it's called init, init. The second process is called kthread, and this is a special process that becomes the parent of child processes that have been orphaned. When a parent process is killed or for some reason is no longer working, the child process becomes the child of kthread. Right? All right. So every process has a PID, that's a process ID, a PPID, that is a parent process ID, and a TID, that is a thread ID. The PID is always unique to a single process. Let me leave this place and type in a command that shows it more clearly. E0. All right, PID, I want to see the PID. I want to see the PPID. I want to see the TID, and I want to see the command itself. All right, I'll just pipe it to less so that it doesn't just run off the screen and we can't see anything. All right, so as I was saying, every process has its own PID. Every process has a parent ID, parent process ID. In the case of the init process, it is 0, and in the case of the kthread-d process, it is also 0. In other words, these two processes do not have parents. Okay, but this third process is a child to the second process, to kthread-d, and so on. That's how. So all these processes here, all right, down to number 19, are children of kthread-d. Okay? So a process will have its own unique ID, which is called the PID, a parent process ID, and a TID. This, a thread ID. When a process is running a single thread, then the process ID and the thread ID are the same number. But when one process has multiple threads, the process ID is the same, but the thread IDs are unique. Right? So these are processes. Let's take a few questions about them and come back for some more.